Okay, so let's start with the first thing, which is we're going to look at what's called Kirchhoff's current law. And a lot of the two laws we're going to talk about today, I kind of mentioned them without formally talking, using the language. But this is Kirchhoff's current law, sometimes called the first law. Kirchhoff's first law. Alright, so this is what Kirchhoff's current law says. The current that enters a node or a junction or simply a point. Usually the word most often used is node, but a junction, you can think of it, or if you want to really go down to basics, some point in the circuit. So the current that enters must equal the current that exits. Okay, the current that enters must equal the current that exits. So, for example, in a series circuit, this is almost too obvious, but if you have a point in your circuit, so let's say you have 2 amps moving this way, okay, and let's say here's a point right here. So the 2 amps coming in here, let's just call this I1, this current coming in here, how should this relate to the current leaving? Okay, so this current should equal this current I2 that's leaving. So we could say, oh, for a series circuit, we would just say I1 equals I2. And actually, if we had another resistor, we choose a point or a node right here, we would say, oh, I2 and I3, I2 is equal to I3. So we talked about this yesterday, but what did we say? What's true for a series circuit? All the currents are the same, right? So the currents through all the resistors in a series circuit is the same, right? And this is just an application of Kirchhoff's current law. Let's see how this plays out in, say, a parallel circuit. So in a parallel circuit, you might have a circuit like this, right? We call this I1, this I2, this I3. Okay, this would be I3 also. Okay, and if we choose a point right here, well, how would I write an equation for Kirchhoff's current law? I1 equals I2 plus I3. Alright, and we talked about that yesterday, right? So the current coming in should equal the 2 currents that are leaving at this certain point. Okay, or if you chose the point here, it would just be the reverse, right? I2 coming in plus I3 should equal your I1 coming out. Alright, so that's Kirchhoff's current law. There is a second law. Kirchhoff has a second law. What do you think we call the second law? Kirchhoff's voltage law. Okay, so Kirchhoff's voltage law. So Kirchhoff's voltage law says this: the sum of all voltages around a loop, this law is sometimes called the loop law, or Kirchhoff's loop law, equals 0. So the sum of all voltages around a loop in the circuit will equal 0. So for example, we have a circuit like this. Okay, and let's say this is the V of the battery, and if this is V1, V2, V3, well, when I add these all up, they should add up to 0. And so how you would do this is you would say, alright, V bat. Now this increases voltage. A battery is going to increase the potential, increase the voltage here from here to here. And then when it drops across a battery, what happens to the voltage? It decreases. It goes down. So you would say, alright, V bat minus V1 minus V2 minus V3, minus V1 minus V2 minus V3, what should that equal? 0. So V battery minus V1 minus V2 minus V3, that should equal 0. Okay, and we talked about this yesterday. I've kind of phrased it a little bit differently. What did I say yesterday is true? Okay, we wrote it like this: V battery is equal to V1 plus V2 plus V3. Okay, so the sum of when you add these up, they should add up to the total. This is inputting the energy. These are taking energy away. So if you start with 100, then you should take away 100 by the end. Okay, so that's Kirchhoff's voltage law. Let's do it for a parallel circuit. Okay, parallel circuit looks like this. Let's just do for 2. Okay, so maybe this is our V1. This is our V2. So what you would do, if this is my V bat, what you would do is you would draw a loop, some loop. You could draw any loop. So we'll draw this loop. Now with the series circuit, it's easy because you only have one loop. Parallel circuit, you could choose this loop, you could choose this loop, you could choose this loop. You have several loops to choose from. Let's just choose this one. So anyways, what this would say is, well, around the loop it should equal 0. So we would have V bat going up minus V1. What should that equal? 0. Okay, V bat minus V1 should equal 0. We talked about this yesterday in a different way. What do we say is true about V1 and V bat? They're the same. Right? V battery should equal V1. And you could do this with any loops that you wanted to draw. So for example, we could do it with this big loop, like this, right? And in this big loop, what would we end up with? V battery minus V2 equals 0. So V battery equals V2. In fact, you could even choose a third loop. Maybe I should be using different colors. What if we choose this loop like this? Okay. In this case, we would go V1 minus V2 equals 0. What would that tell us about V1 and V2? They're equal. Okay, which we could have told from the first two ones, but just wanted to show you that it doesn't matter which loop you choose. We're going to end up with the same results. Alright, so that's Kirchhoff's voltage law.